Today we're going to go over all the double and half angle formulas that we've talked about for the past 2 days. So we're going to do one example, but essentially do 5 calculations for that one example. So here's our first example. They're giving you that secant of theta is equal to -3, and they're telling you that pi over 2 is less than theta is less than pi. So we need to figure out my x, y, and r values. So secant is r over x. So I have like a -3/1, and we know that a radius can never be negative, so the 3 is positive, and we know the 1 has to be negative. Now we have to figure out our y value, so we'll use Pythagorean theorem. So we'll do a -1 squared plus y squared equals to 3 squared. So I have 1 plus y squared equals 9. Subtract 1 from both sides, so y squared equals 8. And then we take the square root of both sides, and when I break this down, I get y equals 2 root 2. So my y value is 2 root 2. And in terms of the quadrant, they're telling you, so pi over 2 is straight up, pi is to the left, so we're in quadrant 2, and x is negative in quadrant 2. So we already determined that. And the whole purpose of finding these values is to set up what sine and cosine is. So I recommend you do that at the top of your page. So sine is y over r, so I get 2 root 2 over 3. And cosine is x over r. So I have -1 over 3. So throughout the whole problem, we're going to constantly be going back to these two values. Okay, we're going to be using sine and cosine values. So the first calculation I want to do is find sine of 2 theta. So on the next screen, we're going to find sine of 2 theta. So letter A, I would like you to find sine of 2 theta. And remember, we talked about all the formulas. So sine of 2 theta is equal to 2 sine theta cosine theta. This is simply the formula that we have to use. So we plug in the values that we found. So 2 is part of the formula. Sine is 2 root 2 over 3. And cosine is -1 over 3. And we can put this 2 over 1 and you multiply all your top numbers. So I can multiply 2 times -1, which is -4 root 2. And then 1 times 3 is 9. So this would be our final answer for the sine of 2 theta. So next we're going to find cosine of 2 theta. And remember, we talked about that there's 3 different versions of the same formula. So I'm just going to stick with that first one we gave you, which was that cosine squared of theta minus sine squared theta. So again, we use our values. So cosine is -1/3 squared minus 2 root 2 over 3 squared. So again, think of it as like twice, so -1/3 times the -1/3 is 1 over 9. And I'm going to write this one out twice because it's a little bit easier to look at if we write it twice. We know the bottom will definitely be 9. So for the top, 2 times 2 is 4, and the square root part of it would become the square root of 4, and the square root of 4 will become 2. So I'm at 1 over 9 minus 4 times 2 over 9. And 4 times 2 is 8. So 1 over 9 minus 8 over 9. So our final answer will be -7 over 9. So that's your answer for cosine of 2 theta. So far we did both double angle formulas. Now we're going to go over the half angle formulas. Again, still using the same values. So for letter C, we're going to find sine of theta over 2. And the formula for that was plus or minus the square root of 1 minus cosine theta over 2. And remember, cosine is -1/3. So I have plus or minus 1 minus a -1/3. And this is still all over 2. And I'm going to change that 1 to be 3 over 3 so that I have common denominators. So 3 over 3 minus a negative 1 over 3. Now that I have common denominators, I can actually subtract them. And actually, we're going to be adding because two negatives make a positive. So we'll get 4 over 3 all over 2. And now we're dividing fractions, so I have to keep change flip. So again, remember this is like technically a 2 over 1. So 4 over 3 times 1 over 2 will be plus or minus the square root of 4 over 6. And why don't we keep it like this before we reduce it, because 4 is a perfect square. So when I take the square to the top and the bottom, I get 2 over the square root of 6. And then the last thing we have to do is rationalize, and that just means we move the square root up. So our final answer is 2 root 6 over 6. So that's our answer for sine of theta over 2. So next we're going to find cosine of theta over 2, and then we'll finish up with tangent of theta over 2. So letter D is cosine of theta over 2. And the formula for this calculation is plus or minus the square root of 1 plus cosine theta over 2. So we're going to essentially follow the same process that we just did for letter C. So I have 1 plus a negative 1/3. And then we change the 1 so that I have common denominators. So 3 over 3 plus a negative 1 over 3. And now that we have those common denominators, we put the fraction together. So I'm adding a negative 1 to 3. So essentially we're subtracting this time. So I get 2/3 all over 2 over 1. And now we keep change flip. So 2/3 times 1/2. You should notice that I have a 2 on the top and a 2 on the bottom. So those 2's are going to cancel. And I'm left with plus or minus the square root of 1 over 3. And when I take the square root of the top and the bottom, I get 1 over the square root of 3. And then the last step we do is rationalize. So our final answer would be square root of 3 over 3. So that's our answer for cosine of theta over 2. And the last thing that we have to do is our tangent of theta over 2. So tangent of theta over 2, the formula for that is plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. So I have plus or minus 1 minus a negative 1/3 over 1 plus a negative 1/3. So both of those 1's are going to get changed to be 3 over 3, obviously. So 3 over 3 minus a negative 1/3 over 3 over 3 plus a negative 1/3. And now we put our fractions together, now that we have those common denominators. So the top fraction would be 4 over 3. Bottom fraction will be 2 over 3. And now we keep change flip. So 4 over 3 times 3 over 2. And you're going to see that you have 3's top and bottom, so those 3's can cancel. So I'm left with square root of 4 over 2, which is just 2. And there's no rationalizing required because there's no fraction. So that's our final answer for tangent. So I hope that clarifies some questions on what we learned yesterday.